Hello everyone, welcome to Roman Just Codes. I'm Roman, and in this episode I'll continue building on our Flicky Home Automation app. I hope you're here because you just finished part 1 of this adding, removing, and managing the metadata for our smart devices in Flutter. In this part 2, I'll pick it up right where I left off on the previous one. We had a lot of fun building the devices page, complete with a list of items for users to select, which takes them to a device details page, which allows them to toggle them on or off and stuff. If not, I got you. Make sure to click on the link on your screen for the previous video, that way you can catch up. Also make sure to stay up to date with the previous videos in the series. So this is what we're tackling in this video. We'll create a form to add the devices we want to manage by asking for the device name, the type of device out of a scrollable list of device types, and the physical outlet we want to send the HTTP request to. We'll capture this data and store it locally using shared preferences to keep it simple, but that's for another video. In this video, we'll build this experience. Let's start. In our utils helper class, we'll create a utility method called showUIModal that takes in a build context and a child to display inside, with an optional dismissible flag and a callback function for when the panel gets dismissed. This method will handle the logic of whether to show our add device form panel as a bottom sheet or a dialog. Let's handle the mobile aspect for now. Later, when we tackle responsiveness, we'll address the other cases. So I'll use a show modal bottom sheet already available in the framework with some predefined values, feeding the child into it, and handle the onDismissed callback when the panel gets dismissed. Let's create our add device sheet widget, which is the wrapper widget that will encapsulate the displaying of our add device form as a bottom sheet. It's made up of a container with the appropriate decoration provided by the theme and predefined styles, wrapping a safe area widget. Whenever our users tap on the Add New Device tile, we'll trigger this functionality, so call the utils.showUIModal, passing the Add Device Sheet widget to it. We'll handle the onDismissed callback later. Oh, there it is. I see it already. Let's keep fleshing it out. I'll establish the several cases in which my add device workflow will be: none to show the initial form, saving for when it's saving, saved for when it's saved, and error to show in case of an error. Pretty straightforward. Our add device sheet will do just that. Listen to the state in which our add device sheet can be at any given time and display the corresponding widget accordingly. A simple switch case covering each case and returning the appropriate widget should do. Oh cool, for the add device states.error, I'll leverage the warning message widget I created earlier. Talk about reusability. We will need to be listening or watching for state changes and displaying the corresponding widget. For now, I'll just switch this property's value as we develop it. Later, we'll use a more fitting logic, like a provider of some sort. Let's start with the Add Device Form widget. Start with a column with its children left aligned. A simple header composed of a row with an icon with the proper size and color from our shared styles and color scheme respectively. I'll know I'll be using a lot of text theme and color scheme, so let me create a few properties up here and reuse them throughout. Add a small horizontal gap, followed by a text widget with the proper styling plus bolded text. We start seeing stuff. Let's continue down the line. Another small gap in between the header and the rest of the content. I'll add a container with the necessary decoration to make it look like a rounded corner input field, since it will be wrapping a text form field inside. To this text form field, populate some of its fields such as the controller, its style and decoration, which is an input decoration instance that is pretty configurable and lets you achieve the desired look and feel for your UI. We'll come back to some of these, but I'm setting up all error-related styles and properties to set the foundation for the validation logic later. This is an important event on the text form field, the onChanged event, which gets triggered every time the user types inside of the field. This callback provides the value of the field as the user types inside. Let's continue. Add another gap below the text field's wrapping container. Add some padding to give it room to breathe, except for the bottom. Let me go ahead and comment out the error text. We'll come back to this during validation. Add a text widget as a field label for our upcoming device type panel with the proper styling applied. Add another gap. Now we want to go off and create the panel that encompasses the list of device categories or types we'll be supporting as far as controlling them around the house. I made this list up so you can make it your own if you want. I'll call this panel Device Type Selection Panel. Create the corresponding file and scaffolding for it. This will be a horizontally scrollable list of custom tiles, similar to the home tiles, but using a mutually exclusive selection logic. Okay, the device type selection panel is in place, let's build it. As usual, we'll need a repository that will feed this list to us. Currently, my list will be predefined, but you can bring it from a service, a local DB, share preferences, a configuration file, what have you. There will be a method called getDeviceTypeList that returns a list of device model instances. Yes, I'll be reusing this model for these purposes as well. Let's start with a few. Notice that you'll have the isSelected set to false and outlet to 0. I'm only using this model for the icon, the label, and the isSelected property and to feed it to my list. The rest of the properties will come from other fields. I don't want to mix up my providers, so I'd like to create a separate provider file just to handle the providers for the add and remove capabilities. Add another provider file called addDeviceProviders.dart. Create a simple provider that encapsulates an instance of our device types repository. We'll also need a viewModel class to handle the UI logic of the items selected and whatnot. So create a viewModel called addDeviceTypeViewModel, which will manage the list of device model instances fed to it. Create a method called onSelectedDeviceType, which takes the currently selected device type and just flips the isSelected flag to true on the matched item from the list and false otherwise. I'll create a helper method here to give me the currently selected item out of the list. Yeah, I will call it getSelectedDeviceType. With that view model in place, create the appropriate provider, a state notifier provider that encapsulates an instance of this addDeviceType view model. Notice how this provider goes and fetches the default list of device types and feeds it onto itself. With my providers created, let me continue fleshing out the device type selection panel. I'll start with a sized box with a predefined height, as I'd like to constrain the height of my scrollable items. My list view will have an appropriate padding and support horizontal scrolling. Test the item builder with a simple text widget for now. I can see them. Prove that things are hooked up as expected. Proceed to develop each tile further. I'll capture the current device type in a local property called deviceItem, as well as set up the foundation for the selected item styles. Each device type selection tile will also have a predefined height for consistency and its contents laid out as a column widget with its children left aligned. A Flick animated icon widget will lead the way, leveraging the icon option and isSelected property from the device item in the iteration. An extra small vertical gap will give it the space needed in between, followed by a text widget for the label property with the proper style. Items start to show up nicely. Let's keep styling them. Add some padding around them, and like before, use an inkwell both for its tapping capabilities and inkwell effect. Add some margin, but only on the right hand side of each tile. On the tap event, try out the onSelected device type method to test the fact that they're getting selected. Nice. Check out how, as they get selected, the icons show animated and with the appropriate selection color. Let's keep rolling. Add a medium gap under our newly created panel. Let's focus on the dropdown that will provide us with the outlet configuration information and metadata. Remember, the outlets are the physical devices we'll use to programmatically send them an HTTP request to toggle them on or off. You can configure light bulbs and other devices from the Shelly family of smart devices, but we'll focus on smart plugs for now. We'll need a repository and a model for that. Let's do them. Our outlet model will keep track of the ID of the outlet, which is just an integer, but I believe you can configure it and make it whatever you want. The label of the outlet for friendliness, the IP address of the device, they must be connected to your Wi-Fi or local subnet, and a Boolean flag that will keep track of whether this outlet ID has been already assigned to a device in our surroundings. We'll keep it here for now and use it as needed. Now, the repository will have a method called getAvailableOutlets, which I'm returning as a future of list of outlet models, as I'm simulating them coming from a service, a database, shared preferences. For now, I'll keep them here as a mock implementation, but remember to provide a concrete implementation on where you have them stored. We need a view model to manage the outlet list and selection, so create a view model called Outlet List View Model, also a state notifier, with a bootstrapper method called initializeList to inject the default list of outlets. Create a provider for the outlet list repository. Since the outlet list returns as a future, I'll create a future provider around it, called the getAvailableOutlets to get the list of outlets and feed it into the viewModel's initializeList method in one single shot. This will return a flag whether the process was successful or not, so we can proceed accordingly. Let's go to the loading notification viewModel and do the bootstrapping and initialization from there. I'll finish it up here in a minute. At least I wanted to have the list of outlets loaded up front during the loading sequence so we can populate our dropdown. Let's build the outlets dropdown now. Go ahead and fetch the list of outlets from its outlet list VM provider. By now they should be cached and ready to use. Use a dropdown hide underline widget, make it a dropdown that manages a list of outlet model instances, and apply the proper styling to it. As the items of the dropdown, use the outlet list instance created above and map them to a list of dropdown menu item instances, feeding the required values to make it work, such as value, and as a child, a text widget. Let's get a basic implementation first to hook things up. We'll come back later to handle the unchanged event. Let's keep sprucing things up. Add some padding around it. Now, let's capture the value selected from the dropdown. We need to populate the value property of the dropdown button hide underline. Let's use a state provider instance to hold a reference to the currently selected item and stash it for later use. Make it nullable since initially it may not have a value at all. Watch the outlet value provider for changes and hold a reference to it. Wire it up to the value property. Now, upon the user changing the value in the dropdown, we'll capture it and set it to the outlet value provider and hold on to it for later use. You can do this straight up here, but I'd rather encapsulate this implementation and hide it behind the outlet list view model. Remember, it is good practice to delegate all logic that powers your UI to a corresponding view model. I'll put it under a method called onSelectedOutlet. Use a ref instance to locate the outlet value provider state provider and store the value accordingly. Cool, the value is changing. But notice how when I change the value, this whole widget rebuilds, clearing the contents of my text field. Well, you should optimize the way you handle input in your forms. We'll fix that in a minute, but first let's finish the form structure. I want to keep all fields as a single unit, so let's wrap it inside another column so I can add the Add Device button below the form fields. I'll use an elevated button for that since I also have a theme for elevated buttons. Add some padding around it to resemble the form's padding. With that, I'm done with this form. Now let's do some validation on this form, shall we? I'm going to capture this Boolean flag, which I'll use to enable or disable the save button on this form once the fields are valid. I'll call it just that. Is form valid? And I'll add a callback that upon clicking on Add Device, it will trigger the sequence of events that will enable the saving of this data. Use this flag to enable or disable the button accordingly. This is just the placeholder logic. We'll come back to it in a second. I'll handle the form validation as a separate provider called Form Validation Provider, where I'll collect all the corresponding data, validate it, and watch it to trigger UI changes accordingly. Hook up the validation logic to our isFormValid Boolean flag. To handle changes in our text field and capturing the value provided by the user, we'll need two additional providers. One to provide the controller that powers the text field, that way it doesn't get blown up upon UI rebuilds. Another one to capture the value obtained from the device name field. I'll have other uses for this property, so I'll keep it separate. So instead of instantiating it in place, we serve it from a provider, effectively lifting it, which exempts it from being overwritten upon UI rebuilds. Now, upon changes in the field as the user types, we want to capture those changes and store them in our state provider created earlier to store the device name. Let's do some validation. Capture the values I want to validate. We'll watch the device name value provider. We'll watch also the outlet value provider. And we'll watch the device type selection VM provider. If either one of these broadcasts a change, this provider will react to it and rerun this logic, which is exactly what we want. Hence the reason why we're watching on them. Out of the device types, extract the selected one. Return a Boolean out of validating that the device name is not empty, that there is a device type selected, and that we have an outlet selected as well. Let's take it for a spin. Enter a name, nope. Select a device type, nothing yet. Now an outlet. Now the form is valid, and the button gets enabled. If you clear the text field, for every character removed or added, the validation kicks in, enabling or disabling the button accordingly. What other validation can we add? Oh yeah, we said that we want to check for duplicate entries. Sure, let's do that. In the device list view model, let's add a device exists helper method, which checks whether there's already an existing entry in our device list from the name being input. I'll execute this additional logic as part of my validation. And I'll reuse this logic also to drive the error message as I type the device name. I'll create a quick wrapper provider that encapsulates this logic. Remember, this is the purpose of providers. Pretty much serve as the glue between your UI and your UI logic, hydrate your UI with data, and handle things on its behalf. Check it out. Start typing. All good? Now add a name that already exists in the list of devices. There it is. It keeps you from having duplicate entries as it goes and checks whether there's one already and notifies you appropriately. What I don't have yet is a way to reset all of these values if I want to back out of them. If I dismiss this sheet, when I bring it back up, I want it to be completely reset. Let's work on that. Let me start adding some of the plumbing of our persistence strategy. I'll create a whole new view model called Add Device Save View Model, which will take care of gathering all the data and saving it, as well as manage the states in which our form should be at any given point during the saving lifecycle. I'll also create a method called resetAllValues. This will be triggered upon dismissing the bottom sheet and takes care of resetting things to default, like clearing the text editing controller, resetting the device type selection, the device type list, outlet selection, the whole 9 yards. So upon dismissing the add device sheet, we'll just invoke this method right here. But first, don't forget to add a provider that encapsulates this view model called Save Add Device Provider, setting it to none by default and feeding a reference to it. Back on the onDismissed callback, read it and invoke it. Do some stuff on it and dismiss. Booyah! I think we're ready to save. Are you? Let's do it. First, we'll save it in memory, and in an upcoming video, I'll show you how to persist your data in shared preferences for simplicity, but the implementation will be agnostic to whichever persistence strategy you pick, as we will keep it nice and decoupled so you can swap it for your preferred approach. Deal? Okay, let's work. For when our Add Device Sheet widget is in the saving state, we want to show a pertinent animation and widget, so let's build it out. We'll call it Saving Device View. We'll start the structure with a center widget, followed by a column with a stack as one of its children, constrained in size by a sized box. I want the contents of this widget to span half the size of the screen, so let's use a fractionally sized box with a height factor of 0.5 to achieve this effect. Let's also constrain the circular progress indicator. Add a flick animated icon, the one with the bold icon on it, and centered. I kind of also want this as a shared loading widget. Let's extract it real quick into its own widget. You know what to do here. Add a small vertical gap and a text label with the proper styling applied. and as usual, animate it using a vertical sliding transition with a fade. Since the saved device view is very similar to it, let's bang it out real quick. Apply the same height treatment as the saving device view widget. Let's simulate the state transitions. First, the state of none should show the full form. The state of saving shows the saving animation sequence, then the saved state, then the dialog gets dismissed and things get reset accordingly. Now let's do this programmatically. Change the Add Device sheet to a consumer widget and watch on the Save Add Device Provider for the state changes. Let me rename it to make it more representative to what it does. Upon triggering the onSave callback, call the Save Device method stub. Let's fill it in. First things first, change the state to saving, followed by a tiny delay for pacing. Fetch all the pertinent values to be persisted: label, outlet, device type. We need to both add it to memory and persist it locally. For now, let's save it in memory. In the device list view model, add a method called addDevice that does just that, adds it to the existing list. Back on the Save Device method, create a new instance of device model built using the acquired values. This is for later, so stay tuned. Continue pacing things by adding yet another delay so users can see the transition from state to state. Then at the end, upon a successful save, dismiss the bottom sheet using a pop against the main navigator via Go Router. Let's take a look and run through the saving workflow. Look at the original list, add a new device, saving, saved, and there it is, saving new devices to our list. And another one to further test it. Let's proceed and do the removal of devices from the list. We'll only allow removing a device when it is off or when it is in the process of being toggled. Let's restructure things a bit on the Device Details panel widget. Wrap the whole thing inside a column and wrap it inside and expand it. That way, it takes most of the real estate in this widget. Followed by a medium vertical gap and elevated button. Notice that this button will only be enabled if the device is selected, meaning is toggled on. Test it real quick. See how the button gets enabled or disabled accordingly? Only if it's enabled and if it's selected as expected. Let's allow the children of this column to stretch. To handle removing of devices from the list, add a remove device at the device list view model level. So pop the widget out of view and then remove it from the list. And also reset the selected device provider instance as well, since this details page only shows the current one being selected. So if it just got removed, no need to keep a dead reference to it. Back on the device details panel, wire up the onPressed event to the newly created method to remove the device, passing to it the current device instance. And done. Add it again and retest it. Nice. Let's remove them all and see what happens. Notice, you can't remove it unless it is toggled off. See? We were ready for this already. Whoa, we did quite a lot this time around. I hope you stuck around all the way until now, as we covered quite a lot of ground, from building more custom widgets, a form to capture the devices we wanted to add, validating the form, saving device data, removing it from the list, etc. In the next video, we'll handle persisting our device configuration data from memory into a more permanent location, such as shared preferences. So if the user dismisses the app, our changes remain in place when we come back. See you on the next video. Hey there, I am Roman from Roman Just Codes. I hope that you found the content of this video very useful, and if you did, make sure to like it and subscribe to this channel. You know subscribing to this channel is free, right? Thank you so much for watching.